These notes are about acids, bases, and pH. So an acid is a solution that has an excess amount of hydrogen ions. So hydrogen ions are positively charged. It comes from the Latin word acidus, which means sharp or sour. And so hydrogen ions are more make the solution more acidic. So how you determine that it's an acid by its taste. It can be sour. It can conduct electricity. It can be corrosive, so it can break substances down. Like if it gets on your skin, it'll break your skin down. Or if it gets on your t-shirt, then you'll have a hole in your t-shirt. And then some acids react really strongly with metal, and then it will turn litmus paper red. It'll turn blue litmus paper red. So we'll talk a little bit more about litmus paper, but for right now, you just need to know that it will turn, if it's a blue litmus paper, it will turn it red. So the use of acids, some acidic acids would be like vinegar, or a citric acid would come from citrus fruits, so like lemons, limes, oranges. Most of these you can eat, like the citric acid. It's not going to hurt you if you eat vinegar either. A lot of people drink apple cider vinegar to make them feel better. Both of those things are acids. So some acids will not hurt you, but some will. Vitamin C is an acid. It's a sorbic acid, and your body actually needs it to function. But now, like sulfuric acid is made to use fertilizers and steel and paints and plastic. So that is not, sulfuric acid is not something that you want to ingest into your body. And then car batteries are also made out of acid. So some acids are not bad, and then others could kind of hurt you, and then some could really hurt you, based off how acidic it actually is. And we're going to talk about determining how acidic things are in a little while. Now, the opposite of an acid is a base, and a base has an excess of hydroxide ions. So hydroxide is an oxygen and a hydrogen bound together, but it's not like water. And water is H2O, so that means there's two hydrogens and one oxygen. A hydroxide means that there's one oxygen and one hydrogen, and it does have a negative charge. So another word for base is alkali, and then bases are substances that can accept hydrogen ions. So you have your base, which is the hydroxide ion, and then you have your acid, which is a hydrogen ion, and they can bond together, and you can easily get water because of that. So properties of bases, they feel very slippery. They're going to taste very bitter, but not sour, just bitter. Most of them are corrosive. They can conduct electricity. They do not react with metals, and then with red litmus paper, they will turn blue. You can use bases for soaps. They're very good cleaning products because they're they're corrosive. So they break down anything that was stuck to a surface. So most cleaning products are going to be bases. So hydronium ions react strongly with substances. Like I said, they're corrosive, so they're going to break it down. Chalk and oven cleaner are also examples of bases. And then your blood is actually a basic solution. Now, I talked about how we would determine how strong an acid or a base is, because I said, some of them are not harmful where some are very harmful. And we base this scale off the pH scale. So a pH scale measures how acidic or how basic it is, and it ranges from 0 to 14. Now, we are able to stay at around 7. We're comfortable. They don't hurt us around 7. Now, if we get much lower, it kind of starts to hurt us, and if we get much higher, it kind of starts to hurt us. But 7 is neutral, so like pure water is going to have a pH of 7. Basic solutions are going to have a pH of 7. Now, acidic, the pH scale is tenfold. So if it has for example, one solution has a pH of 1 and a second solution has a pH of 2. The first solution is not twice as acidic as the second. It's 10 times more acidic than the second. So if you look at acids, let's actually go back. So if you look at acids, they're 0 to 7 or 0 to 6, and then bases are 8 to 14. So you have 0 is going to be the most dangerous you could possibly have, which is hydrochloric acid. And then you have lemons at 2, and then vinegars between 2 and 3, and you have an apple around 3, tomatoes are 4, bananas are around 4 to 5. Then you have milk, which is going to be closer to 7. Water is at 7. Remember I said that your blood is a little basic. It's in between 7 and 8. Baking soda is between 8 and 9. Soap is around 10. Ammonia is between 11 and 12. And then drain cleaner is at 14. So when you separate out acids and bases, remember that acids are less than 7 and bases are more than 7. Now, acid-base reactions can occur, and just like with chemical compounds, the properties of the acid and the base are going to change whenever you put them together. So if you put an equal amount of acid and an equal amount of base together, it actually is going to neutralize. So you can see from the picture, we have a pH of 12 as our base and a pH of 2 as our acid, and we combine them and we get a pH of 8, which is pretty close to neutral. It is still on the basic side, but we're in that comfortable range. So whenever you have an acid-base reaction, it's called neutralization. And that means you're just neutralizing the properties of the base and the acid. So here are some examples of acid-base reactions in the list of salts. So you have sodium chloride, potassium iodide, calcium chloride, potassium chloride, calcium carbonate, and ammonium nitrate. I'm not going to ask you to remember all of these things, but you just need to know that there are different types of salts because of the compounds that they're made with. Now, those two compounds are a chemical reaction. We've talked about that, how you have two or more elements chemically combining, their atoms are rearranging to get a compound. Now, all of these compounds are salt, but there are different types of salt based off the chemical composition of them. So like sodium chloride, for example, is what we use to put on like our French fries. It's food flavoring. But ammonium nitrate is also a salt, but it's used in fertilizers. So you just need to know that there are different types of acid-base reactions, and they are chemical reactions. So you are getting something new, and you're rearranging your atoms. And you need to know the pH scale. Now, I told you I would talk to you about litmus paper and pH paper. So here is a video about pH paper.
pH paper is used. pH paper is used to determine if a solution is acidic, basic, or neutral. This is determined by dipping part of the pH paper into a solution of interest and watching the color change. The packages that pH paper comes in often includes a color-coded scale indicating the pH that something has when the paper turns a certain color. For instance, if the paper turns a dark greenish blue, the pH may likely be around 11 to 14. If the paper turns red, the pH may likely be around 1 to 4. How does pH paper work? The pH paper changes color in different pH solutions is because of the chemical flavin. This molecule, which is an anthocyanin, is soluble in water and changes color in the presence of various types of solutions. The pH paper is coated with this chemical, gives the property of changing color at different pH solutions. In the presence of an acidic solution, it turns red. In the presence of a basic solution, it turns greenish blue. In the presence of a neutral solution, it turns light green.
Okay, so you can see from the video that all of your entire pH scale can be tested with pH paper. So you would just literally dip the paper into a solution and the color changes on the paper because of the chemicals on the pH paper. Litmus paper is very similar to this. So litmus paper, there's red litmus paper and there is blue litmus paper. Now, it will turn different shades of colors based off what you are putting it in. So here is a picture of what happens. So you have your hydroxide, which we know is a base, so it turns blue, and then you have your acid over here, which it turned red. So it kind of just gives you an idea of this is a base or this is an acid, where pH paper gives you a specific number for the pH scale. So it doesn't just tell you if it's an acid or a base, it actually tells you how acidic or how basic it is. So if you have any questions about acids, bases, or pH, please ask Ms. Quinlan.